We were looking into the routing protocol topic. Previous class explained you how important it is to know the difference between the routing protocols. The purpose of routing protocol is to discover routes, the remote destination, unknown destination, the remote networks that are not directly connected to this router are dynamically learned, and the routes that are found as best are put into the routing table using which the packet can be forwarded. So you no need to write static route. You no need to know the complete topology. See, knowing complete topology is not that easy in a large network. There may be many portions of network which are managed by different engineers. So now, when you enable protocol, a common routing protocol, the protocol will make it as one big network by discovering. We no need to discover. Routing protocols, they discover networks. So you see, today everyone wants to have automation. Everyone wants to have software-defined uh, network management. Why? When we allow the software to manage, that can do more accurately than a human being. That will be more vigilant. Even when we tired, when we are tired, when we are sleepy, or when we are when we have slept, the softwares don't sleep. They're more vigilant than human being in finding a broken network, converging the traffic according to the new paths, because the old path is broken. For a human being to discover a broken network and to reconverge the traffic through another path is going to take a long time. But the protocol, which is always vigilant, which is always looking for changes, this makes the convergence more faster. So we depend on routing protocols, especially in a large network. And we saw that there are various routing protocols like OSPF, RIP, RIP, Routing Information Protocol, RIP, OSPF, Open Short Path First, Enhanced Interior Gateway Routing Protocol, EIGRP. And there is also some other protocol which we focus on BGP, in CCNP, like BGP, Border Gateway Protocol, ISIS, which we focus on Service Provider Track, intermediate system to intermediate system. These are the popular protocols. Now, OSPF is what our today's focus. Open Short Path First. So we'll be learning OSPF to a limit, to a Ccna level. Open shortest path first. Whenever we speak about OSPF, this is what you should remember. It is a link state routing protocol. Link state routing protocol. Why this name, link state routing protocol? We see many links join together to form a big topology. I just drawn few links and a few routers. There may be many links, many routers. You may have many redundant links. Now every link has got a network. See, just connecting this wire is not enough. We want this device, let me call it as RK and RT. RK and RT, if they need to communicate through the wire needs a network. Likewise, another network, another network, another network. We have many networks. Each wire will have one network at least. See, you can have multiple networks on a same wire by creating sub-interface. I'm not getting into it now. What is the purpose of routing protocol? To discover networks which they are not connected directly. Now, how the discovery happens in OSPF, how the network discovery happens in OSPF, every link status is advertised. Every link status is advertised. Why? When we advertise a link status, even the network on the link is advertised. Okay, fine. If network is advertised, is it sufficient? No. For example, to reach a destination to if simply this link network called 2222 is advertised, no use. This link has got a bandwidth. According to OSPF, there will be a cost on the bandwidth. Likewise, here there will be a bandwidth. There will be a bandwidth. So depending on the bandwidth, the cost will vary. So those costs also should be advertised so that when I want to go from RL, I'll go via this path because the cost is cheaper for me than going via this path. These paths are too long. I have only one link. Here I have two links, another path, another two links. And then only I can reach this 2222. So for RL router to find the best path, you got multiple paths. Routing protocol not only provides a route, they also provides metric to reach the destination. So to know the metric in the link state network, the cost on the link, the subnet mask of the network, the router ID which advertises this network, all these are sent as a link state. Using that link state, the other router will evaluate the paths like RL was doing it. Other routers, every router receives the link state advertisement from all other routers. Collecting the link state advertisement from all other routers, for each destination, they pick one best path and put the best path into the routing table. In short, what I want to say is, it is the link state advertisement makes this protocol a best routing protocol. Link state advertisement makes this protocol a best routing protocol. That is why OSPF is called as link state advertisement. Let me tell you one thing. You are in a new country. There are two ways to go to your hotel where you want to stay. You are in a new country, you just landed in airport. You have never been to the country. Yeah, it's the first time. And you only booked the hotel, but you have never been to the hotel before. You just did online from wherever you are. You just did online and you landed in the airport of that country. There are two ways in which you can reach the hotel. Number one, you can go to a cab and say, I want to go to this hotel. And this guy will know the route to reach the hotel because he is taking many passengers every day. He must be knowing the location of the hotel. Now, this is one way of knowing the hotel. You just get into the car, the driver takes you to the hotel, but the route he takes is not in your hand. He will take any route that he likes or any route that he knows. That may not be the best route, but he takes you in the route because he wants you to pay more. That is how, in the olden days, Indian taxi drivers do. They will take long route so that he will pay them more. The meter will show more. He don't have any big customers, so you got into the cab, and for him it's a lucky day. He takes you a long ride and then drops in the hotel, and you pay the bill whatever the meter shows. But even though you have achieved what you want, you have reached the hotel, it is not guaranteed that it's the best path. You reached, but you might have come through a very far route. So this is one way of knowing the route to reach hotel, meaning you depend on others for you reaching the hotel. Now you went in the path that the driver took. You know the path that the driver now taken you from airport to the hotel. You don't have any other route now. You learned only one route from airport to the hotel. Which one? the one which the driver showed. The one which he showed may not be always the best route because he wants to make more money, more bill, big bill. He might have taken you in a long route. And if you say that is the best route because you know only that route, is it that best route? No, it is not really a best route. Maybe best, may not be best. This is one way of learning route. We call it as learning by rumor. Learning by rumor. Because it may be right, it may not be right. It may be the best path, it may not be the best path. This is one way of learning route to reach a destination. The second way is you take the map. Before you take taxi, you first take the map from your bag. Position yourself in the map. Where are you now? In the map. Airport. Fine, I'm here. If I'm in the airport, where is the hotel? Position the hotel in the map. Okay, the hotel is in this place. Now from airport to hotel, how many lines connecting? How many roadways? How many railways? How many paths we have? And then which one is the best path? Maybe in kilometers. Which one is the small number in kilometer to reach? Fine, you saw the road now. In the map, it's very clearly shown there are 4 paths to the hotel. For example, this is airport. And you have taken the map and you can see this is the hotel you want to reach. In the map, you see there are 3 routes. One like this, the other one like this, the other one is like this. There is also one more which is like this. So you saw 4 routes in the map, and you are very sure that this is the best because just one. Just maybe one, let's say, take it as kilometers. Each wire is 1 kilometer. This is just 1 kilometer. So you have chosen the path which is best. And now you tell the driver, go this way. He drops you, small bill. You got into the hotel now. So you knowing the routes and picking one best route is another way. You have learned really the best route. In this, you have not dependent on anyone to dictate the best path. You only dependent on the map. In the map, you are provided with all paths. Among all paths, one you saw it as the best because there is no toll and the kilometer is less. You picked the road and you went through the road. Same way. When link state only is advertised, you will be able to form this map. Every router will be able to form this map in their memory. Now, using the map that is formed by collecting the link state advertisements from all the routers. See, every router will send link state advertisement. For example, if our L sends a link state advertisement. This RJ knows that okay, we are connected to RL. And now when RL forwards the link state advertisement along with its own link state advertisement, RT will be now learning that I'm connected to RJ and the RJ is connected to RL. And now when RT sends the link state advertisement, RL knows that I'm connected to RT, RT is connected to RJ, RJ is connected back to me, then we are connected like this in triangle. So RL knows now the triangle. Likewise, when LSAs come this way, this way, this way, everyone now knows that this is how we are connected. Everyone knows the map now. Every router knows the map now. After a certain point. Now they keep sending LSAs. After a certain point, you got the complete picture of the topology. So link state advertisement helps to discover the map. Now once the map is discovered, you, means each router, can find the best route for themselves. See, the route advertised to reach this network by this router will not be cheap. The route advertised by this router will be cheap. How do you know that? Because you see the map in front of you. Otherwise, you will not be knowing. You have to blindly believe, like you believe that taxi. So whatever the route the taxi driver takes, that is what you will think it as the route to reach hotel. That is learning by rumor. There is no link state advertisement in the first example. So that's one way of learning route. Neighbor router gives you the best route. Neighbor router says, let's say for RL, RT is the neighbor router, right? RT says, I always go through this path to reach 2222. Now, if RL takes that as the best path for itself, then it's a long route for RL. This may be a best route for RT, but not for RL, you know. So the best way of picking the path is know the topology completely first. Don't simply ask the neighbor how to reach. Just collect the link state, means all the connections and the bandwidth on the connections, the network on the connections. Collect all the link states advertisement, link status of every link. After collecting, you will know the complete topology. Now, keeping the topology in front of you, decide the best path to reach the destination. This is how it needs to be done in order to pick the best path, right? Yeah. The protocol that does like this are OSPF and intermediate system to intermediate system. Only these two protocols uses the link state advertisement to form the map of the topology, map of the network, means topology, to form the map, and every router is going to have a common map. Right now, every router will be having common map because they have shared that link state advertisement. Is that right or not? You see, you are in airport with a map of Dubai. You are in the airport. I am in Carifor, Burjman, Dubai. We both have same map, but I and you cannot take the same route to Dragon Mart because I locate myself in the map in Burjman, you locate yourself in airport, and we both wants to go to the same destination called Dragon Mart. See, we are in different location, but trying to go to same destination. Because you are going to same destination, will the path be same for us? Not at all. So the common map that we all have is common, but the path we are going to take to reach destination is not going to be same because we are all in different starting point. That is why we should not depend on others to know our path. You know, you should not call someone, hey, what is the best path to go to Dragon Mart? To whomever you call, he will say the best path for him to reach Dragon Mart. His location and your location is not same. So how can we take his path as how can I take his path as my path? Not possible. It may be taking to the destination, but it will be a long route for me. Some other protocols work like that. Work like what? Asking the neighbor, knowing the route through the neighbor's advertisement. We call those protocols as learning by rumor protocols. Example, RIP, Routing Information Protocol, learns by rumor. Whereas OSPF and ISIS uses link state advertisement, using which the map is found, the map is built dynamically, and using the map, the best path to destination is determined by each route. So I have given maximum explanation what link state routing protocol means. They depend on the link state advertisement, not the neighbor's advertisement. All other protocol other than this two depends on the neighbor's advertisement. Neighbor will advertise what? Their best path. They won't advertise all paths. The neighbor will advertise whatever they know, their best path. Their best path may not be best path for you. Learning routes from the neighbor through neighbor advertisement is learning by rumor, because that advertisement that is given to you may be best for you, may not be best for you sometime. It may be best for your neighbor, not for you. Yeah, I repeat again, except these two protocol, all other protocol learn by rumor. They depend on rumors. They believe rumor is the best. Sometime it will be best, sometime it will be not best. Because it's a rumor. Don't forget, OSPF is a link state routing protocol. ISI is also link state routing protocol, but we will not be seeing this protocol in this course. It's for service provider track. Okay, next. In the previous class, I told you OSPF's administrative distance is 110. What is administrative distance? It is the number that shows how much preference is given for this routing protocol. Listen, when we have a router with multiple routing protocol, when we have a router with EIGRP as well as OSPF everywhere, we have EIGRP and OSPF on every router, assume. Now both the routing protocol will try to find the best paths according to their knowledge. EIGRP, according to its knowledge, it will say, hey, come this way to reach to. OSPF will say, come this way, don't go that way, come this way. This is the best way. So what path to be taken now? Let's say, for example, EIGRP says, let us go this way to reach to. OSPF says, let us go this way to reach to. OSPF says this way, EIGRP says the other way. Actually, both the ways can take you to no doubt in it, but which one you're going to follow? You cannot follow both. This router M cannot take both. It should pick one and ignore the other one. Which one will it pick? That will be determined by an algorithm called routing information base, RIB. So RIB will say, fine, don't fight. Okay, give me what you want to say. I need to go this way. Fine, okay. What OSP, what do you say? Sir, please come this way. Okay, let me decide. Thanks for your recommendation. Your job done, good job. And then RIB will say, fine, bye-bye. Now RIB will take those two information, EIGRP and OSPF. Alright, which one's administrative distance is lower? According to Cisco, EIGRP's administrative distance is 90. So RIB will say, I will go this path. Why? Lower the administrative distance, more preference for the protocol. So, even though I was praising OSPF for this many hours, last class, this class, who is going to determine which path to be there in the routing table? It is not OSPF or EIGRP, it is RIB. Routing information base will decide which route to be there in the routing table. So according to the routing information base algorithm, the protocol whose administrative distance is lower, smaller, that routing protocol given route is what more preferred. So EIGRP route will be installed into the routing table, not OSPF. But if you go to OSPF protocol and change this number to a lower number, now RIB will say, I will not take this path because 90 is bigger than 80, so I'll go this way. Understand very well. EIGRP is Cisco's protocol, and this router is Cisco's router. So they have given more preference to their own protocol by giving 90. You may not be happy with the EIGRP after learning this course. So what do? You go and change the administrative distance. That's why they have given the flexibility of changing it. The default is 110. You just go and change it as 90, and you will see the RIB algorithm will start using OSPF path instead of EIGRP path. This is the use of administrative distance. When we have more than one routing protocol, to pick one routing protocol's path recommendation and ignore all other recommendations from other protocol, you use this number as a tiebreaker. You should not forget the use of administrative distance, because this is one of the important questions the interviewer will ask you if you are saying I have completed CCNA. I always ask this question if someone says I finished CCNA. Sometimes this will be the first question that I ask. What is the role of administrative distance? What should we say? It is the preference value given to a router, used whenever we have more than one routing protocol, suggesting routes to RIB. RIB will use this number as a tiebreaker. RIB will choose the path recommended by the protocol whose administrative distance number is smaller. The default administrative distance for OSPF is 110, but it is configurable. You can go and change it to 80 or 70 or increase it to 200. That is up to you. It is flexible. The number is not fixed. By default, it is 110. Again, I want to tell you one more thing. OSPF 110 is only in Cisco. If you take other vendors, they will have their own preference value. What is preference value? It's for administrative. The other word of calling administrative distance is preference value, no? How much you prefer. If you prefer more, then give small number. The protocol with small number is preferred, right? Now, what I want to say here is, if you are applying for a Juniper network engineer, not Cisco network engineer, you should very clearly tell them, the interviewer, that in Cisco, administrative distance of OSPF is 110. In Juniper, you can say, I don't know. Or you can say 25 if you have already known. In Juniper, OSPF administrative distance is 10 for internal network, meaning the network coming from OSPF domain. Networks that are redistributed from some other protocol into OSPF, they're called external. For that, administrative distance is 150. Right, so for Cisco, it is different from other vendors. So every vendor, see this is almost same for other vendors. Juniper, Huawei, Alcatel-Lucent, which is Nokia. I think they have the same number for OSPF, except Cisco. And even for RIP, 100 is given by these three vendors except Cisco. For static route, Cisco and Alcatel-Lucent is matching, but Huawei and Juniper, they vary. For connected, everyone is given 0. Means connected is more trusted, right? So smallest the number. Smaller the number, more we trust. Smaller the number, more preference. So 0 means what? Directly connected. Of course, you prefer the directly connected than the route given by the routing protocol. So the question that was asked is, if I have two routing protocol, OSPF and EIGRP, can we do load sharing? So OSPF shows this path, EIGRP shows this path. The question that was asked is, can I send 500 packet via OSPF path, 500 packet via EIGRP path? The truth is yes, but that won't come under dynamic discovery of path or dynamic load balancing. It is manual. Like what? That 500 path, the 500 destination out of 1000, you need to manually map to this OSPF, and the remaining 500 destination you need to manually map to this EIGRP. In another word, out of 1000 network, 500 you need to filter in EIGRP and allow in OSPF, and the remaining 500 you need to filter in OSPF and allow in EIGRP. That is what called as manual load balancing, which is not at all actually dynamic. It is not considered as load balancing using routing protocol. It is policy based routing. That is how I can say. It won't come under what you are asking. You can do like this. You can give 500 networks to OSPF to handle. The other 500 to be handled by EIGRP. That is policy actually. That won't come under load sharing using multiple routing protocol. See, I told you very well, very clearly. RIB, routing information base, is going to pick the protocol whose administrative distance is smaller. Then how can you expect load sharing between routing protocol? Not possible. And if you want to do, this is how you can do. You can tell the RIB algorithm, see, for those 500 networks, OSPF's administrative distance is only 80. For rest, it is 110. And that is how you can do manually the policy-based load sharing. Did I answer your question? All right. Now, just two things we have seen so far for the last 45 minutes. OSPF is a link state routing protocol because it uses the link state advertisement to form a map. Using that map, every router will position themselves in the map and find the best path by their own to various destinations. And this is the best approach in finding the path. That is why OSPF is more popular. Whereas the other routing protocols listen to the route advertisements, route updates from the neighbor. According to that neighbor's advertisement, the route advertisement, this router decides the path. That will not be always accurate. Sometimes there may be better path, but because the neighbor did not speak about the path which is better for you, you have no chance of learning it. We call it as learning by rumor. Other than ISIS and OSPF, all other protocol depends on neighbor's route update. Neighbors are not going to advertise all possible paths. Neighbors are going to advertise only their best route to you. So you are not going to know the complete topology. Correct? No, if you're asking someone how to go to airport, that person will say the route which he knows. Go straight, सीधा होगी left तगोली. Go straight and take left. There up போய் left எடுங்க. Right? But that may not be the best path, or that may not be the only path for you. There may be many paths, but for this guy, he knows that only path is best path. He tells you only that path. What about the remaining paths? He has not told you and you did not know. So there's no chance of learning the topology in the other protocols. OSPF and ISIS, they really learn the complete topology because they learn link state, every link status, not the best route from the neighbor. Neighbor is supposed to send all the routes. Whereas in other routing protocols, neighbors are saying only their best. Now, next is every protocol has got a metric to measure a path. If you are allowed to pick a path, you pick one path. If I am allowed to pick a path, I may be in the same place where you are, and we may be trying to go to the same destination, but the path I pick and you path may not be always same. Why? For me, I have my own metric in my mind to say this is best. You have another thing in your mind to say that is best. So maybe I'll see a path which is wide and smooth. You may see a path which is short in distance. You don't care whether it is narrow or wide because you have bought a nice electric scooter. But I have an old big Bolero. I cannot come through that path that you have chosen. So my metric is smooth road, wide road. Same place we both start, same destination we want to go, but I choose a route which you have not chosen. You chose a road which is short because you want to save some battery power, and you got a new bike. For me, I want a smooth and wide road so that I no need to pull the brake every now and then. And I don't want to go through congested road. See? Likewise, like you, like me, like him, like her. There are many protocols. Every protocol will have its own style of deciding which is best path and which one is the second and third best path. You know, the criteria, the metric, the measurement, the scale through which it measures is not same. Whenever I ask how big is that, my mason used to say, sir, it is 3 feet high and 3 feet breadth. I don't understand much feet thing. I know only centimeter because in schools we used 15 centimeter scale and 30 centimeter scale. And sometimes he will say in inches, which is not familiar for me. So if I say, I'll say in centimeters, which he is not familiar. So he uses inches or feet as a metric to say this is this much big. I use centimeters to say this is this much big. Right, likewise. Every routing protocol has got its own way to measure the paths and pick one path which is best for them. OSPF uses a auto cost, meaning automatically calculated cost. How it automatically calculates the cost? Based on bandwidth. Based on bandwidth. More the bandwidth, the automatically calculated cost will be lower. So cost is the metric of OSPF. RIP, Routing Information Protocol, decides a best path based on hop count. Hop count. What is hop count? How many routers in the middle? One path. If I take this path, there are 5 routers in the middle before I reach the destination. Here is the destination. From here I am going. If I go this path, 1, 2, 3 hops. To the same destination, if I take this path, 1, 2, 3, 4, 5 hops. So RIP will say this is the best path. Based on hop count, RIP will decide the best path. EIGRP uses composite metric, which is having a combination of bandwidth and delay. Based on this combination, a composite value is generated, and the path whose composite value is lower will be considered. We'll talk about this in detail when we go there, EIGRP and RIP. Actually, talking about BGP is too early, but I want to just finish it by saying a few words about BGP's metric. There is no metric for BGP. BGP, no metric. It has got only attributes. So Attributes are configurable, can be modified. If someone is not studying, give him nicely every day whenever you see him. He will start studying. That is how I started studying when I was a small boy. Otherwise, I would have not studied. Nicely, I'll get from my tuition master and my father. Nicely, my fingers will become like brinjal. Every finger will be like brinjal only. That's how I started studying. My attribute changed. My character changed. That is attribute. That is not metric. You keep beating robot. Will the attribute change? It will be same always. The character of robot will not change because robots have got metric, but human being has got attributes. I may be doing wrong, but when I'm given nicely, I molded my character. I started studying because human being have got attributes. Likewise, BGP has got attributes. BGP has got attributes. Rest all other protocol have got metric. If you remove cost from OSPF cannot function because that's the only metric OSPF depends on. But in BGP, you have a lot of plug and play attributes. You can plug and you will have different path selection. If you remove, there will be another path selection. That is attribute. When people are watching us, we behave so decent. We take cutleries and we eat so gently, slowly for half an hour. When we are hungry, also we don't behave, we don't eat fast because others are watching us. When no one is watching, come on, what is cutlery, man? Come on, my God has given me nice hand. Grab it, put it in the mouth, finish it in 3 mouth, the entire plate. See, that is the attribute. We change according to what has been plugged in. If people are around looking at us, our attribute is X. When no one is watching, our attribute is Y. Metric is not like that, always the same. Right? So, hope I made clear what is the difference between metric and attribute. BGP uses attribute. We'll continue this in our next class. So, in this class, we just again had 3 points in OSPF. We learned 3 points: metric and administrative distance and what type of protocol is link state. It's a link state. OSPF is a link state. That's all. Nothing more. Hope you enjoyed today's class. If you have a question, you can ask me now. Otherwise, we'll meet again same time tomorrow. Any questions from anyone? No questions. Wonderful. Have a good day. Have a nice evening. Take care. Bye-bye.